This is standard 8 SPA2. This deals with statistics and probability, and particularly this part deals with scatter plots. In this case, we need to know that straight lines are widely used to model relationships between two quantitative variables, and we're going to see those. What we've done in the past is we've looked at linear equations. Now we're talking about lines that are essentially drawn as best fits between data that are not exactly perfectly linear. For scatter plots with a linear association, we need to informally draw a line of best fit for the data, and then informally assess how well the line of best fit models the data by judging how close the data points are to the line. So let's look at our first example here, our example on this. I think it'll make sense when we do an example. First off, a fuel tank in a car can hold 13.5 gallons. The table below shows the number of miles traveled, see miles traveled, and how many gallons of gas have been used, gallons of gas used. Plot the points. Okay, I'm going to tell you, we've already done that. I've done that for you, in fact. I plotted the points. Gallons used, miles traveled. 0 gallons used, there was 0 miles traveled. According to our plot up here, when we had used 2.3 gallons, we'd gone 75 miles. So see, 2.3 gallons, 75 miles, so about halfway between 50 and 100. Okay. Same situation on each one of these. We've used 4.5 gallons. We've gone about 120 miles. So let's look at that. 4.5 gallons, about 120 miles. So see, we've got the other points here that were on our thing. So they've all been plotted. Now, let's see what else it tells us to do. We're going to mark all the things that it tells us to do. Let me get us a marker here so we can do this. It told us to plot the points. Whenever you've got a multiple choice question, make sure you number it so you do it all. We plotted the points. Describe the relationship between the variables. Well, let's look and see. Is our relationship linear? Is it positive or negative? We've talked about that before when we're talking about relationship between variables. Well, if we put a line of best fit in here, basically draw a line that fits with the data, it's going up, so it's a positive relationship, and it is linear. The points are close to the line. In fact, it's a close association to this linear, positive linear relationship. Okay, so describe the relationship between the variables, the two-part, positive. Oops, let's write this again. Positive, linear, relationship. Okay. Now it says to, if the data has a linear association, determine a line of best fit. Well, didn't we do this down here? Didn't we draw a line of best fit here through here? This is called the line of best fit. It's the best line I could draw between those data, the one that would most closely fit those points. And see, I've just basically drawn it in after I plotted the points. Okay, so we did that. Okay, now number 4. Do you think the line represents a good fit for the data set? Let's look and see, and then why or why not? So is it a good fit? Why or why not? Let's look and see. Looks like it's a pretty good fit, right? The points are very close to the line. Good fit. Points are close to the line. See, we're just being qualitative. We're not putting numbers to it yet, right? Points are close to the line. We're just describing it. Okay. Now let's see what else it's asked us. What is the average fuel efficiency for the car in miles per gallon? Average fuel efficiency. Average fuel efficiency. Miles per gallon. Let's go down here and look at this. Miles traveled per gallon. Wouldn't that be the change in Y over the change in X? When we've got the change in Y over the change in x. Isn't that our slope, the slope of the line? So I need to find the slope of this line of best fit. To find the slope, I need to find 2 points that I can get some good information on. This point here is at 0, 0, isn't it? Let's find another point that's close to the line that we can pretty much figure out what the data point is. This point is pretty much close to that line, isn't it? Let's see what it was, what that point was. It's 4 point something. I'm going to go back up here and see exactly what it was because it's close to the line. That was 4.5 and 120. We're going to use that point, 4.5 and 120. Now, we know when we're talking about changing y, we're changing x. If this is my x value for this first point and my y value for the first point, and this is my x value for the second point and the y value for the second point, what I need to do is I need to find the change in y here. And my change in y is I'm going from 0 to what? 120. Okay, so the difference in that is 120 minus 0. 120 minus 0 over, let's see what this is, to 4.5, right? That's at 4.5. Whoops, I went to the wrong one, didn't I? Goes to this point, not that one. Wrong one up there. 4.5, okay, and 0. The difference in the y's are 4.5 and 0. 4.5 minus 0. This is up 120. This is over 4.5, right? Changing y over changing x. That would give me 120 over 4.5. 120, what? 120 miles per 4.5 gallons. Let's divide 120 by 4.5 and we can get our miles per gallon. 120 miles is how far you go on 4.5 gallons. I've got 26.7. So my slope is 26.7. And what were my things? Remember, changing y. Y is miles. 26.7 miles. What is my x? My x is gallons. 26.7 miles per gallon. Okay? That's my fuel efficiency, 26.7 miles per gallon. Any questions on that one? Well, I guess you can't really do questions with me, but that's how that works.